Let's do 73 times 52, starting with the partial products method. I'll start it vertically this time, but it doesn't matter. So I could start with 2 times 3, which is 6. We'll go ahead and do 2 times 70 next, which is 140. Next, I'll do 5 times 3, but that's technically 50 times 3. So that would be 150. And then 50 times 70, so 5 times 7 is 35, so 50 times 70 would be 3,500. And then I'm going to add all that up. So I'm getting 3,796. I'm going to go ahead and show that horizontally as well, and then I'll do the area model. So 73 is really 70 plus 3. 52 is really 50 plus 2. So if I were to do first, outer, inner, last, I could start with 70 times 50, my first two terms, which is 3,500. Then I could do my outer terms, 70 times 2, which is 140. Next, I'm going to do my inner terms, 3 times 50, which is 150. And then finally, I'm going to do my last terms, which is 3 times 2, or 6, and add all that up. So get 3,796. And then for my area model, it does not matter which side is which or how you draw your rectangle. So if you drew your rectangle a little bit longer on the left than it is on the top, then you would just want to make sure that the longer side is the bigger number. In this case, 73 is bigger than 52. If you did it the other way, where the longer side is the top, then you just want to make sure the bigger number 73 is across the top. It doesn't matter either way. So I'm going to go ahead and do 73 across the top, since that's my longer side. And then the 50 plus 2 is going to be along the left-hand side. And then I'm going to go ahead and color code, but then write these products in there. So this one's going to be 50 times 70. This one's 50 times 3. This one's 2 times 70. And then this one's 2 times 3. So there's my completed area model. And then I'm going to go ahead and do lattice next. Since these are both 2-digit numbers, it doesn't matter which one goes on the top and which one goes on the right, but I do need a 2x2 box. So I'll split it up like that, and then I'm going to go ahead and draw my diagonals that go down and to the left. And I'm going to put my numbers on the side. I'm just going to stick with 73 on the top and 52 on the right, but it doesn't matter. So then I'm going to go through and do my multiplication. For this box, it's going to be 7 times 5, which is 35. The top right box is going to be 3 times 5, which is 15. The bottom left is going to be 7 times 2, which is 14. And the bottom right is going to be 3 times 2, which is 6. And I'll enter that in as 0, 6. And then I'm going to add along each diagonal. So this diagonal is only a 6. Here I have 5 plus 0 plus 4, which is 9. Here I have 1 plus 5 plus 1, which would give me 7. And then this diagonal only has a 3 in it, so I'm getting 3,796. And then finally, let me show this with the standard algorithm. Again, I'm just gonna list 73 first, but it doesn't matter since they're both 2 digits. So I'm gonna do my multiplication by starting with the 2 times each digit in 73. So 2 times 3 is 6, 2 times 7 is 14. Then when I do the 5, I'm going to make sure that I put a 0 placeholder. 5 times 3 is 15, so I'm going to regroup a 1 and write a 5. And then 5 times 7 is 35, plus the one I regrouped is 36. And then add these together. 6 plus 0 is 6, 4 plus 5 is 9, 1 plus 6 is 7, and then just the 3. And I get the same answer.